Hey, welcome back. We are doing Circles Part 2, that unit, and we're doing the third lesson, Circumference and Arc Length. Okay, so we're in the middle of circles. Let's see what you guys can do with circles. Okay, we just finished up all these chords and things, so we're kind of shifting gears in this lesson, and we're going to look at circumference and arc length. And I need to kind of define those, so let's take a second and look at your note-taking guide and kind of go through this together. Okay, circumference, that's just your distance around a circle, right? If you're an ant and you got to walk around a circular path, you just walk all the way around, and that's the circumference. It's kind of like perimeter, but just of a circle. And there are two formulas for it. One involving the radius, which is 2 pi r, or one involving diameter. And personally, I prefer this one. I prefer just d times pi, diameter times pi, because I can do the diameter, radius to diameter in my head. So I think it's a little bit easier. So let's look at numbers 1 and 2. It says find the circumference of each circle. Well, if we use this d pi formula, all we have to do is say, okay, what do we have? We have the radius. The radius is 14.3. What would the diameter be? I would just double it. So that's going to be 28.6. I don't even need a calculator, do I? So I'm just going to take this and mentally, in my head, I'm just going to do my think bubble here. I'm just going to take 2 times 14.3, and I'm going to get, 28.6. And then all you do is stick a pi next to it, and there's your answer, okay? Now, this is in inches, so I'm going to have to stick my unit by there. Now, this is a linear measurement because we're not covering a space. It's just a measurement around. So we would just leave the units as just inches. Okay, now this one on number 2, we're given the diameter is 33. So it's very simple. You just stick a pi next to it. So d pi is just 33 pi. And this is meters, and voila, we're done. So they're very easy, very forward problems. Now, let's apply that to something new. Okay, what is arc length? Arc length is the length of an arc that's part of the circumference. Now, I don't want you to get confused between arc measure and arc length. Arc measure is in relation to 360, and that relates back to your central angle. So if I were to draw an angle from A to P to B, and let's say this angle was 120 degrees, we learned that AB has a measure of 120 also, but that's not its length. The length is related to how big the circle is or how small the circle is. Okay, so we're talking actual measure, or the length of the arc, okay, which is a part of the circumference, and that's where this formula comes from. Arc length of AB, and this is a very simple formula. You're going to take the measure of arc AB. So you are going to need to know that central angle, so you know the arc measure, as a fraction of the circle. So as a fraction of 360 times 2 pi r. Well, what is 2 pi r? 2 pi r is really just circumference, or d pi. Okay? So you can plug in circumference if you know it. You can use 2 pi r, or you can use d pi. All of those are interchangeable in this formula. So what we're going to do is we're going to find the circumference, and then we're going to multiply it by the fraction of the circle. So if you only know part of it, you would just take a fraction of that circle. So let's look at a couple examples here and how they go back to this formula up here. Okay, so I've got a circle, and the radius is 5. And I've got an angle measure of 50. So if I figured out the circumference is equal to d pi. So that would just be, well, radius is 5, so diameter is 10. So the circumference is just simply 10 pi. But that's all the way around. I don't want to know this distance all the way around. I just want to know a part of that. Okay, that's where this fraction comes in. Well, I only have 50 degrees out of 360 degrees. So you're going to take 50 over 360 times d pi, or 10 pi. So let's simplify that. Okay, both of them have zeros, so I can divide by 10 and just cancel the zeros out. So 5 over 36 times 10 pi, over 1, right? We always have it over 1. So I have 50 pi over 36. And that will reduce. Both are divisible by 2. So what's that going to be? 25 over 18 pi, or 25 pi over 18. And that would be in inches. And there we go. That's an exact length. So if you're asked for exact lengths, you're going to keep it in terms of pi and no decimals. And that's your answer. Okay, so let's see if we can figure this next one out. Okay, this time we're given the diameter. So what's the circumference part of the formula? That's just 34 pi. So I'm going to take the measure over 360 times the circumference, where circumference is d pi, so I'm just going to stick in a 34 pi right there. Okay, now let's write the angle. We're trying to find the arc length of AB. So what's the measure of that arc? Well, it's the same as the central angle, so it's going to be 150 over 360 times 34 pi. Okay, I think I wrote that twice. Sorry about that. Okay, divide by 10. I'm just going to cancel the zeros out. Now I can also divide by 3, can I? So if I divide by 3, I'm going to get 5/12 times 34 pi, and 5 times 34. I don't know that one. 170 over 12 pi. Okay, now 170 over 12 will reduce. So let's go back in. And that reduces to 85/6. Okay? It's going to be 85 over 6 pi, and that's centimeters. Okay, so you're getting the hang of it. It's a fairly straightforward process. We're just kind of plugging in. Okay, we've got these two problems, one with a radius, and this one where we're actually going to have to work backwards. Let's try this one just to make sure we've got it. It says find the radius. This is a backwards problem. Now, I'm going to show you a little trick for the backwards problems that basically takes the formula and just makes it a little bit simpler. Okay, I'm going to show you a proportion, and this always works if you've got a backwards problem. Now, these first two were forward problems. We were finding the arc length. So anytime you're just going forward and finding arc length, you can just use that formula. But if you've got the arc length and you got to work backwards to something, try this. Okay, we're going to take the measure over 360 as a proportion is equal to the arc length over circumference. Okay, so let's try it this way. It's basically just this formula cross multiplied. It's just cleaned up a little bit. Okay, so let's try this one. So what's the measure of this problem? Well, the measure of the angle is 85 degrees. So this is just the central angle over 360. So see how that's just a fraction of that circle equals arc length over circumference. Well, the arc length is given to us as 12, right? So what I'm going to do is I'm going to plug a 12 in for arc length, and I'm going to solve for C. Okay? Now, C, you can leave a C in there and then go back and find d pi, or we can use a d pi, or we can use pi r, 2 pi r, because circumference is any of those. For right now, I'm just going to use d pi because it's my favorite. D pi. Okay, so now when you get to here, you're going to cross multiply, and that's what makes this so simple. 85 times d pi. So I'm just going to put 85 times d pi equals 360 times 12. Well, of course, I don't know that off the top of my head, so 12 times 360, and that's giving me 4,320. Okay, now I need to solve for d, don't I? Okay, so that means I need to get rid of 85, and I need to get rid of pi. So let's divide by 85. And so I'm going to take this answer and just click divided by 85. And that gives me 50.82. So d pi equals 50.82. Now I don't know if you're comfortable with this, But d pi is circumference, so we just figured out the circumference. So if it asks you for circumference, you're done. You just stop here, because that's circumference. But we're trying to find the radius. So we need to get down to the diameter next, don't we? Well, pi, remember, is just a number. What's the value of pi? 3.14. So now we're just going to divide both sides by pi. So I'm going to take what's in my calculator, and I'm just going to divide it by pi. And my pi button on here is right here. It's on top of the caret key. So I'm going to do second function, and I'm going to hit this arrow key, and up comes pi. And so I'm getting 16.18. I'm going to round it off to 16.18. Okay, so diameter equals 16.18. That's my diameter. Am I done yet? No, it says find the radius. Okay, what do we know the relationship with diameter and radius is? I take the diameter and I just divide by 2. And I get 8.08. So radius is 8.08. And I'm done. Okay, that's kind of lengthy, but that's how you work that backwards problem. Okay, so let's look at number 6. You can watch that problem again if you need to. But this one says find the circumference. We're given the arc length is 81.64. We're given this arc is 260. We got to find the circumference. Whew. Well, this is a backwards problem. So what did I say about backwards problems? Use these proportions. So we're going to do measure over 360 equals arc length over circumference. And since we're finding circumference, we're actually going to be able to stop our problem earlier. So let's see. What's our measure? Our measure is 260 over 360. So we have more than half the circle, don't we? Okay, 81.64 is my arc length that I know that's associated with that 260. See how that's a proportion? They're both on top. And then I don't know circumference, so it's on the bottom as C. And it's the circumference is the whole circle, so you can see how they relate. The arc length we know, and then 360 goes with circumference. Now let's do some cross products. 360 times 81.64, and that gives us 29,390.4 is equal to 260C. Now I'm going to divide by 260, and I get 113. So circumference is 113.04, and guess what? I'm done because they asked me for circumference. So I can stop at this point. Okay, the only thing I do need to add are units, and I didn't do that on the last problem, which I should have. But if you go in, oh, it's in inches, so that's in inches. And there you go. And that's how this formula sheet works. Okay, so let's look at these together. Okay, on the next page, you've got some practice problems. And I'm going to work through them. But you can stop the video here, work through it yourself, and then see what you might need to. You can just skip around and look at the answers you need to. So I'm going to go ahead and work it, but feel free to use the video however you need to. Okay, let's match these. So you got these and you're matching, okay? So match the value with what's given. Okay, look what we've got. We've got OB is 4. That's the radius, right? So we know that the diameter must be 8. So the radius is 4 and the diameter is 8. Are they asking us for the diameter? They are. So number 8 is saying, what's the diameter of the circle? It is 8, which is D. Okay, let's do another one. We need to find the arc length of AB. Well, before we do the arc length, it might be easier just to find the whole circumference. What's the formula for circumference? It's d pi. So what's our diameter? 8. 8 pi. Well, guess what? One of our answers is 8, isn't it? Okay, so look. Number 10 is asking us for circumference. So that must be B. Okay? So now let's try to find the measure of arc AB. Well, what does this tell us? That tells us this is 90 degrees. A measure means an angle measure. Since this is a central angle, we know that AB must also be 90 degrees. Okay, so that's 90, which is F. Okay, now let's find the length of either ACB or the short angle or arc AB. And then we're going to find the length of the semicircle. Okay, well, we know the circumference is 8 pi. So maybe we can use that to help us. Okay, to find an arc length, remember we're going to take, let's take, I'm actually going to do number 11 next. Find the length of AB. Okay, AB is this arc, and we know that it has a 90-degree angle associated with it. So I'm going to take the measure over 360 times circumference. Well, we figured out the circumference already is 8 pi. So 90 over 360 times 8 pi. Now on this one's kind of easy. You know why? We can look at it and say, you know what? This is 1/4 of the circle, isn't it? So 90 over 360 simplifies or reduces to 1/4. So what's 1/4 times 8 pi? Remember, we're not cross multiplying here. We're multiplying across. 1 times 8 pi is 8 pi over 4. So 8 pi over 4 is 2 pi. Okay, so that 2 pi is the length of arc AB. Okay, so that's how you work that one. Whoops, I kind of went off the screen on you, didn't I? There we go. Okay, so that's 2 pi. Now, we've already figured out the whole distance around is 8 pi. If I take 2 pi out right here, what's left for this side? Well, 8 pi minus 2 pi, which is 6 pi. So ACB, which is number 9, what's the length of ACB? It's 6 pi, or C. Okay? And then, what's the length of the hemisphere or semicircle? Well, that's half of it. Well, if the whole distance around is 8 pi, what's halfway around? Yes, 4 pi. So that would be the length of the semicircle on that circle. So there you go. Those are the answers. F, D, C, B, A, E. So hopefully you got all those, and you can double check if you need to. Okay, so now let's look at these. These are very straightforward. Find the circumference of each circle. Remember, circumference is d pi. So if the radius is 3, what's the diameter? 6 pi centimeters. Okay, radius is 20. Diameter is 40 pi inches. Okay, this one's given as a diameter. So all we do is stick a pi next to it. So that's 15 pi. And again, this is really easy. Diameter's given. You just stick a pi next to it and you get 30 pi. Okay, so those straightforward finding circumference given either radius or diameter. Okay, now let's find some lengths. Okay, some lengths here. We need to find the length of AB. Now, from the problem up at the top, what do we know about that 90-degree angle? What fraction of the circle is it? It's 1/4. Okay, so 90 over 360 reduces to 1/4 of the circle. So what's 1/4 of the circumference? What's 1/4 of the circumference? Well, circumference is d pi. The radius is 7, diameter is 14. So what's 1/4 times 14 pi over 1? Multiply across 14 pi over 4, so 7/2 pi, and that's in inches. So that would be the length of AB. Okay, let's try number 18. 18. We know that's 120. We know the radius is 6. So if the radius is 6, the diameter is 12. Okay, so let's plug into our formula. Measure over 360 times d pi. The measure is 120. And what do we know 120 is? What fraction of the circle is 120? Hopefully you recognize it. It's 12 over 36 if we cancel the zeros out. 12 over 36 reduces to 1/3 because 120, 120, and 120 adds to 360 times d pi. Well, diameter we just said was 12, so times 12 pi over 1, multiply across. 12 pi over 3 is equal to 4 pi, and this is in feet. So there we go. So that's 4 pi feet. Okay, number 19. Number 19. We have 45 degrees. 45 out of 360. That may be a little trickier, but that one reduces. And you can use your calculator if you want. I'm going to show you a quick little trick on your calculator. Okay, if you go to put in 45 divided by 36, you're going to get a decimal answer. But if you want to convert that to a fraction, go to your math button. So click math, and the very first choice is fraction. Enter twice, enter, enter, and it converts it to the fraction for you. So it's 1/8. 1/8 of the circle. It sounds like a lot at first, but once you do it a few times, it's quick. Okay, so 1/8 of the circle, and then diameter times pi. Well, radius is 12, so that means diameter is 24. So times 24 pi over 1, multiply across. 24 pi over 8 is 3 pi centimeters. There we go. Okay, so that's how you're going to work that one. Now, these next few are asking you to find different lengths. Okay, see if you can do number 20 on your own. It's a forward problem. You're just finding an arc. Okay, now this one is a backwards problem. So you're given the arc length is 15. You're trying to find the circumference. I'm going to actually show you two ways to do this problem. Okay, the first one is to think about it in slices. Okay, how many slices of 60-degree angles are in the whole circle? Well, if I take 360 and I divide it by 60, I get 6. So if I drew this in, I would have 6 slices, wouldn't I? Okay, if each one of these is 15, I would have 15, 15, 15, 15, 15, and 15. So I'd have 6 15s. So I can take 15 and just multiply it by 6, and I can have my answer. Okay, that is just straight number sense. It's 15 times 6. So the answer to that problem is 90. Okay, it's just 90 because I have 6 slices. Now, if you are a formula person, I've got to have a formula. This is what you're going to do. Okay, remember that little proportion I gave you. Let's use the proportion. The measure over 360 equals the arc length over circumference. Okay, the measure is 60 over 360 equals arc length 15 over circumference. I'll leave the C in there. Cross products. Okay, so I'm going to take 360 times 15, and I get 5,400. 5,000, let me draw a little squiggly here so we don't get confused. Okay, is equal to 60C. So now I'm just going to divide both sides by 60. So divided by 60, and I get 90. Ah, same answer, right? So C is 90. I got the same answer using either method. Okay, so it's really up to you how you want to think about that. Can you think logically with number sense, or do you need to stick with a formula? Choose your poison there. Okay, so let's look at this one. And this one is asking us to find the radius. So this is another backwards type problem. So let's use this measure over 360 formula. Okay, the measure over 360 equals arc length over circumference, or d pi. It doesn't matter, whichever you want to use. Okay, so our measure, what's our measure right there? It's 90 over 360. And I'm going to go ahead, for simplicity's sake, and I'm going to reduce that. I know that's 1/4 of the circle, so I'm just going to reduce that. Okay, now arc length, what's our arc length? 18 pi. 18 pi over circumference, which is d pi. You know something? There's something really easy we can simplify there. What can we do? We can cancel out our pi's, can't we? So I just have 18 over diameter. Ooh, that's kind of nice. Now I can do a cross product. 18 times 4. 4 times 18, I should know that. 72. 72 equals d times 1, or just diameter. Oh, that's nice. Okay, so our diameter is 72, but they're asking us for the radius, aren't they? So I need to take 72, divide it by 2 to get 36. So that means my radius is 36, and I am done. Whew, that was a lot of work. Okay, so you've learned the circumference formula in 3 forms. Circumference can either be 2 pi r or d pi. Well, I guess 2 forms. 2 forms. And then you've learned how to do the arc length. The measure of the arc over 360 times the circumference in any of the 3 forms. If you're given circumference, if you got the radius, got diameter, use which one you want. And then you can go forward and solve for arc length. Or you can go backwards using the proportion. The measure over 360 equals arc length over circumference. And the circumference can be replaced by d pi or 2 pi r. Okay, hope this video is helpful, and ask us if you need help on anything.